All right. So, kind of picking up where we left off yesterday. If I can get this mouse to work. There we go. So you've got that module 10 quiz, module 10's participation quizzes from the last 2 days. Those are all due at the end of the day, Sunday. Today we'll have for the next participation quiz. This module 11 quiz will be released tomorrow after class, and we'll have tomorrow's participation quiz. All of those due at the end of the day, Sunday. We'll kind of start with these module 11 slides. You've got the practice problems for this module as well. And then you'll kind of start to see the files for module 12 and 13 pop up. We'll start module 12 on Friday, finish it next Monday. Next Tuesday, Wednesday, we'll finish module 13, review Thursday, final exam next Friday. Okay. So that's kind of where we're going. Any questions for me logistically? Otherwise, we'll probably kind of jump right into material here. Oh, shoot. I don't think I put it up. I've got it on my laptop. So I have a kind of figure out your grade tool that I created. That'll kind of help you as you're starting to kind of think towards the end of the semester. I dropped those 2 lowest quizzes, dropped the lowest module reading. So if you want to see what your score would be with that kind of factored in, I've got an Excel file where you can enter your own individual grades. I will make sure that I have that for tomorrow's class and kind of walk you through how you would use it. So you can kind of think about like the grade you're seeing on Canvas is kind of worst case scenario in the sense of it's factoring in your lowest scores right now. This Excel file, if you enter in your quiz, your participation quiz scores, I drop the 4 of those, your module readings, it'll kind of drop the lowest and show you, reflect to you what your current grade would be with those lowest dropped. Now, obviously, we still have quizzes to be taken, so it's not like a definitive, because if you just don't take a quiz, obviously that we're just going to pull your grade down. But then it also kind of has a spot where you can put in hypothetical grades for the final exam, and it would then kind of spit out at you kind of what your final grade in the course would be. So I'll bring that tomorrow so we can kind of walk through it together. I'll just kind of maybe give you a little bit more insight as to how to use that tool, but you'll see it pop up here on Canvas. I'll put it up as soon as I get back to my office after class. Okay. Any questions before we dive into module 11 here? Okay. Why is this? Got a little black box up here. I guess it's going to distract me, but that's okay. It's not going to hide anything that we're talking about. I'm not sure exactly why that's right there. So last 2 classes, we were talking about perfectly competitive markets. So we know that that's kind of our baseline. We know that every market in practice is not going to be perfectly competitive, right? So we said we had to have free firm entry and exit. Every firm was a price taker. However, in reality, we know that there's going to be barriers to entry and exit. Usually we think about it as more as barriers to entry, right? If one firm owned a key resource, so this would be something like, if somebody owned all of the, gold in the world, or maybe they own all of the airwaves, right? Or maybe they own, all of the, what am I looking like all the gasoline reserve, whatever it is. If they own a key resource, no one else can really enter that market if they're the only firm that has that resource, right? So I think De Beers is another example. They have like almost all the raw diamond mines in the world. So if you want to, create rings, you're going to have to buy diamonds for them. The diamond market is what we would call a monopoly, right? One firm owns almost all the entire entire resource there. Sometimes the government gives exclusive rights. So you can think about, the post office, different cities, different towns, they give different utility companies rights to be the only electric provider in that area. Now, usually, if we have the government kind of creating these monopolies, we'll call these natural monopolies. And we'll talk a little bit more about those, probably not today, probably next class, and how the government can regulate those so that we don't have as much of deadweight loss from these monopoly markets, which we'll also talk about later today. So these natural monopolies would be kind of this idea of, electric companies. Why do we see potentially, right? Why do we only have one postal service? Well, it's not as applicable now because you have competitors like UPS, et cetera. But if you think about back in the day, there's huge fixed costs to have a transportation network that can take mail across the entire country. And so potentially there's only enough demand in some markets that supports one firm. As soon as a second firm enters the market, now both firms would have negative profits. One would leave, we go back to one firm. That's the idea of a natural monopoly. Okay, so we'll talk more about these later on. But for now, we're thinking about, we know these monopolies exist, right? We see there's examples, and maybe nothing is a true like perfect monopoly, but kind of like a perfectly competitive market, we want to know what the extreme looks like, and then most markets are somewhere in between. So we started out with these perfectly competitive markets. Nobody has any influence over the price. We're now going to look at a market where only one firm is producing this product. They have complete control over the price. So if we think back to a perfectly competitive firm, their demand curve was simply this horizontal line, right? They had to take whatever that equilibrium price of that good was as given. That was their price they had to set. That was their marginal revenue. And so we really couldn't see a firm change the quantity, right, if they try to charge a price any different than what the current equilibrium price is. Okay? So if we think about, for these competitive firms, we had the price was equal to their marginal revenue. That won't be true if we think about a monopolist. Okay, so for a monopolist, they face the entire demand curve. Right? We now no longer have a difference between the firm's demand curve and market demand, because if there's only one firm, the demand they face would simply be the market demand curve. So what's going to end up happening is they're going to sell a higher quantity than a perfectly competitive firm would choose. And they're also going to choose they're going to choose a lower quantity than the perfectly competitive firm would choose, and a higher price. Okay? So if a monopolist wants to sell more of its product, what is it going to have to do? It's going to have to convince more consumers that they want to buy it. So the first consumer has the highest marginal benefit. If I want to convince the second consumer to buy, I have to lower the price a little bit. So we know that marginal revenue won't quite be the same thing as price now. Okay? So you can think about the most extreme example. If I wanted to sell one unit, maybe if I charge a price of 100, I could sell one. My marginal revenue would be 100. If I want to convince the second person to buy it, maybe I have to lower the price to, just to make the math easy, 50, right? Well, if I'm lowering the price to 50, what's the additional revenue I'm now making on each unit? Only $50. So my marginal revenue won't be the same as kind of those different prices I can charge. Okay? So just to kind of look at this in kind of table form before we go too much into kind of visuals here. If I have different quantity price combinations, what is the total revenue of the monopolist going to be? So these price quantity combinations, that's just my demand curve. Okay? Total revenue, same equation we've used before, is just price times quantity. So when I multiply price by quantity, that should give me my total revenue here. So 0 times 4.5, 1 times 4, 2 times 3.5, etc. Okay? Now my average revenue, think about it here, when I was selling one unit, I was selling it for a price of $4, right? So the total revenue of 4, average revenue, just like we have average cost, take the total divided by quantity. Here, 4 divided by 1 would be 4. Now, if I want to sell that second unit, to convince that second person to buy it, I have to lower the price a little bit. And this doesn't have to be necessarily a different person. This could be the same consumer, and I'm convincing them to buy, more of this product, the second unit. But I usually talk about it in terms of people just to, I don't know, I think it kind of helps solidify it in your mind initially. So if I want to convince that second consumer to buy this good, I've got to lower the price. They didn't have as high of a marginal benefit as the first person, right? That was the fact that we have this downward sloping demand curve. So if I want to convince them to buy, I have to lower the price to $350. Well, what's my total revenue? 7. How much on average am I making per unit? 7 over 2. I'm only making on average now $350 per unit. So our average revenue, as we want to sell more of this good, we've got to lower the price. That's going to lower our average revenue. Now, what will also end up being true is, well, what about the marginal revenue? Well, every time I lower the price, right, how would I calculate marginal revenue? Well, if I lower the price, it's going to change my total revenue. Just like marginal cost, change in total revenue, just like marginal cost, which was a change in total cost over the change in quantity, marginal revenue will be a change in the total revenue divided by a change in quantity. Okay? So notice here, total revenue is going up by 4, change in quantity is 1, my marginal revenue starts out at 4. To sell that second unit, what's the marginal revenue? Change in total revenue is 3. Change in quantity is 1. Marginal revenue is 3. So notice marginal revenue is going to be decreasing. And that comes from the fact that, yes, I am selling more units. However, in order to do that, I had to lower the price. Okay. So I might still be able to increase my total revenues, right? Total revenues are going up for these quantities, right? But the additional revenue I'm earning by selling a higher number of units, lowering that price, is going to be going down. Now, eventually, that marginal revenue is going to become negative, right? You can kind of think about it once I get down here. Okay, yes, I'm going from selling 5 to 6 units, but I've now had to lower the price so much that I'm making a much lower amount per unit. So the fact that I'm selling more units, but less per unit, maybe my total revenue goes down. I want to go here for a second. So just to kind of some shorthand, another way of thinking about this. If my total revenue is price times quantity, well, in order to sell more units, I've got to lower the price. So anytime I've got, so let's say I drew them kind of equal here. Let's say if I lower the price a little bit initially, I convince a lot more people to buy this good. So that impact on total revenue of the decrease in price is going to be overshadowed or kind of canceled out by that huge increase in the number of units I'm selling. Or essentially here, the change in revenue is going to be positive. Now, if I ever end up with a scenario where I want to sell more units, but in order to do so, I've got to decrease the price a lot, well, there, what effect is going to win out? That decrease in price is going to cause my total revenues to decrease. So there I'd have negative marginal revenue. Okay. And we'll kind of come back to this here in a second. You might be able to start thinking about this. Looks kind of similar to something we talked about, which was elasticities. Okay. So we've got this decreasing marginal revenue. Excuse me. If I wanted to put then marginal revenue on the same graph as my demand curve, well, the demand curve is just the combinations of price and quantity. Excuse me. Oh, sorry. So if I just graph those points out, there's my demand curve. Well, notice what's happening with marginal revenue. So it's a little bit goofy in this example where we have not a truly continuous curve, but you can kind of notice my marginal revenue is decreasing faster than my demand curve, right? Or said differently, the slope of my demand curve, which I'll kind of show you here in just a second, is going to be a little bit flatter than the slope of my marginal revenue curve. Okay. So in this example, how would I calculate the slope of this demand curve? It's just the change in the y-axis divided by a change in the x-axis. So what's on my y-axis? Price. So every time I go up by 1 unit, that change in price was 50 cents divided by a change in quantity of 1. The slope of my demand curve here would be negative 0.5. Now, notice what's true about my marginal revenue curve. Well, it's decreasing as well. What's the slope of my marginal revenue curve? Well, every time I go up by 1 unit, right, the change in my y-axis, change in marginal revenue is 1 divided by a change in quantity of 1. Oh, its slope is negative 1. It's twice as steep as my demand curve. Okay. So what's going to end up being true is we have a demand curve that'll end up being we have a marginal revenue curve that will be twice as steep as our original demand curve. Okay. So another way of thinking about this, I'm looking at the equations here. Oops. Oh, come on. All right. So we just said my total revenue is price times quantity. Okay. But we also had these demand equations where we could write out kind of the price as a function of the quantity demanded, right? So whenever we were looking at this graph, here we kind of had our quantity demanded, here was our price, here's our demand curve. There's some equation behind that, right? Where price is a function of the quantity I want to sell. So I can rewrite my total revenue equation as, well, I'm going to just substitute in for price the equation that I have from my demand curve times that quantity I'm selling. So I'm just kind of plugging this in here. Well, if I want to find my marginal revenue, that's a change in my total revenue coming from a change in quantity. This should look similar to, and I usually use kind of the triangle, but really this is just a derivative. Right? So if I have this total revenue equation, what will it always be? Well, I'll kind of distribute this just so we can look at it a different way. So I have A times Q plus B times Q squared. Right? So if I take the derivative of that equation in respect to Q, my marginal revenue will always be equal to whatever that intercept of my demand curve was, however, plus 2 times Q. So it's going to be start at the same point as my demand curve, but it's going to be, oh, what did I forget here? Sorry. 2 times B, right? It's going to be twice as steep. Okay, I was writing too quick there. So, right, take a derivative of this, it's 2 times B times Q. So it's the same exact equation as my demand curve, but twice as steep. Okay. All right. So in our other example, we had our slope of the demand curve B was negative 0.5. And then we said the slope of our marginal revenue was what? 2 times B. So it should be negative 1, right? 2 times negative 0.5. So twice as steep as our demand curve. Okay. Any questions on this idea before we keep moving? Okay. So whenever we want to sell more units, and I kind of already alluded to this, but we're going to have a price and an output effect. So I'm going to raise my revenues when I sell more units because I'm increasing the quantity I'm selling. But I'm going to, in order to do that, have to lower the price. A lower price is actually going to reduce revenues. So if I'm interested in the total effect, right, I want to know, okay, I know I'm selling more units, but I'm doing so at a lower price. Well, I want to make sure that if I am selling more units, I'm still increasing my total revenue, or we have positive marginal revenue. Right? However, what you'll notice here, because we have a price and an output effect, that marginal revenue won't simply be the same as that price associated with our demand curve. Our marginal revenue will always be at any quantity. Where are we at on the demand curve at this quantity? Well, here would be the corresponding price. Here's the corresponding marginal revenue. Notice here, price will always be above the marginal revenue for a monopolist. Okay, so the price that they're kind of going to be able to set will always be above their marginal revenue. Right? Or said differently, marginal revenue is below the price, right? So we can see, like in our earlier example, there can be eventually we get to a quantity where marginal revenue becomes negative, right? Like our example, I think it was going from a quantity of 5 to 6. Or you'll notice I even drew it up here, right? There is a quantity where if I want to sell past this point, I've got to lower the price to sell more units. I could end up with quantities where the marginal revenue is negative. Now, you can kind of think about for a firm, is this going to make any sense? Well, we said we only produce as long as it's just like a perfectly competitive firm. We want the marginal revenue to be greater than or equal to the marginal cost. Even if my marginal costs were 0, if I have negative marginal revenue down here, is that going to make any sense to ever produce those units? No. So we know the monopolist will never produce at a quantity where they're on the negative portion of that marginal revenue curve. It just wouldn't make sense. Even if there's 0 costs, which there's an opportunity cost to everything, so we know it's even going to be, even if it's small, it's slightly above 0. So they'll never kind of be choosing a quantity on that negative portion of their marginal revenue curve. Okay. So I'm going to kind of try to connect this, and I'll draw this out with some additional things that I think will help solidify this idea. But initially, right, if we go back to module 4, we talked about elasticities. The demand curve at low quantities, we said, is going to start out as elastic. Okay. And I'll kind of write something out to just kind of remind us of this, but in words, Why was this portion elastic? Well, because when quantity is small, the percentage changes in quantity are going to be very large. When price is high, change in the price will be small percentage changes. Our elasticity was the percentage change in price divided by a percentage change in quantity, or sorry, a percentage change in quantity divided by the percentage change in price. So we're going to have an elasticity that's greater than 1, right? A very large number divided by a small number. So we said initially demand will be elastic. What's going to end up being true in that range, for all the quantities where demand is elastic, if we lower the price and sell a high number of units, that output effect will be larger than the price effect, and our marginal revenues will be positive. Eventually, we get to a point where once my marginal revenue becomes negative, that's going to be whenever demand is inelastic. So there, quantity is high, so changes in quantity are going to be really small percentage changes. Price is low, so changes in the price will be really large percentage changes. So really, a really small number divided by a really large number, we're going to have an elasticity less than 1. And there, when we have inelastic demand, that output effect isn't going to be near as large as the price effect. And so that price decrease is going to be what kind of dominates, and we end up with a negative marginal revenue. Okay. So a different way of looking at this with monopolies, elasticity, and total revenue, kind of walk through it here, writing some additional things, right? So we said up here, and this is, once again, kind of review. So if I've got my demand curve here, there is going to be some point where it's unit elastic, right? So we said kind of the elasticity of demand is the percent change quantity demanded coming from a percentage change in price. Okay. So initially, with low quantity values, we said in this range, the percentage change in my quantity demanded is going to be much larger than the percentage change in the price. Okay. So that would tell us, okay, if my numerator is larger, I'm going to have an elasticity greater than 1, or demand starts out as elastic. Okay. And then down in this range, I've got really small percentage changes in my quantity demanded. When price is low, changes in the price will be really large percent changes in price. A really small number divided by a really large number, we said our elasticity would end up being less than 1, or we're on the inelastic portion down here. Okay. So inelastic, elastic. Now, the reason why my marginal revenue is going to look something like this, it's twice as steep as my demand curve. Now, if I think about, if I wanted to map out, let's see if I can get all this on the same screen here. At every single quantity, I want to figure out what total revenue is going to be. Okay. Well, if I think about total revenue, that was price times quantity. Okay. So initially, when demand was elastic, if I want to sell more units, that percentage change in the number of units I'm selling is going to be really large. And in order to do so, I have a much smaller reduction in price. So what's going to be happening overall to total revenues? Well, my output effect is going to dominate. So total revenues in this range, as long as demand is elastic, I know this percentage change in my quantity demanded is greater than that percentage change in price. So the effect that's driving total revenues up will dominate for every quantity in this range. I could map this out to a total revenue. Well, what's happening as I sell more units and lower that price? My total revenues are increasing. Okay. So anytime demand is elastic, by lowering the price, the monopolist is increasing their total revenues. Or what's an increase in total revenue? A positive marginal revenue. Okay. Now, there will be a point when marginal revenue is equal to 0. Well, if marginal revenue is equal to 0, what's the change in my total revenue? At that very specific point, the change in my total revenue or my marginal revenue would be equal to 0. Okay? I've hit the maximum point of total revenue. Now, if I want to keep selling more units, When demand becomes inelastic, well, there, that percentage change in my quantity demanded is going to be relatively small. In order to sell more units, I've got to lower the price. That percentage change in the price is much, oh, sorry. Should be a down arrow, there we go, is much larger. So which one's going to win out? Well, now, once I'm on the inelastic portion, that price effect is going to dominate. So if I sell more units in this range, yes, I'm selling more units, but it's at a huge sacrifice to the price, the huge percent change in the price that I'm selling these goods for. So I start to see that there. Now my total revenues, if I want to sell higher quantities, will start to decrease. What is a decrease in my total revenue? It's negative marginal revenues, right? So here was my marginal revenue curve, right? Anytime demand is elastic, in order to increase total revenues, I know that I should lower the price to sell more units. Now, I haven't even factored in costs yet. So even if we just had a monopolist where they're trying to maximize total revenue, we know that where would total revenue be maximized? At this unit elastic point where marginal revenue is equal to zero. So even if they had zero costs, what would be the quantity that maximizes profits? Or in this case, if you don't have any costs, maximizing revenue would be maximizing profits. It would be right at that unit elastic point. So once we know we start factoring in costs, the kind of optimal profit maximizing quantity has to be somewhere in this range where marginal revenue is positive. Okay. Any questions on that idea before we keep moving here? Okay. So, well, draw something else out. I think I've gotten the slides, but I think given what I'm doing here, it makes some stuff. Based off what I said, we can do it right now. So, in general, what is our monopolist profit maximizing decision going to look like? So it kind of already went through. We've got our market demand curve. Marginal revenues would be twice as steep. We said if marginal cost was zero, so let's say I had marginal cost be equal to zero, doesn't really make sense in practice, but if that was the case, monopolists make the profit maximizing, choose the profit maximizing quantity the same way perfectly competitive firms would. They'll produce as long as that marginal revenue is greater than or equal to marginal cost. So where do they stop? They stop or they're indifferent at that point where they're the same value. So even in the most extreme scenario, right, this monopolist would be on the, well, if marginal revenue is equal to zero, we said that is the unit elastic point. Will we see this in practice? Not likely, because in practice, what do we have? Increasing marginal costs, right? And in fact, they often don't start down here at zero. I'm drawing this as a little bit inaccurate. They're probably even up here, but same thing will apply. If I have marginal costs that are increasing, well, where is my marginal cost curve then going to hit my marginal revenue? Has to be at a lower quantity than that unit elastic point. For every quantity below that unit elastic point, we said the elasticity of demand would be greater than 1, or we're on that elastic portion of our demand curve where marginal revenues are positive. So we know that the monopolist is going to choose a quantity where marginal revenue is positive. That coincides with being on the elastic portion of the demand curve. Okay. So they use that same profit maximizing rule that a perfectly competitive firm would. So no difference there. However, once they choose that quantity, unlike these perfectly competitive firms that just faced a horizontal demand curve, well, for these perfectly competitive firms, that meant when the price was equal to marginal revenue was equal to marginal cost, the price they set was simply equal to whatever their marginal revenue and marginal cost were. With a monopolist, what's going to be true? Well, my marginal revenue now isn't the same as the price associated or the marginal benefit associated with every single quantity here. So think about it this way. If I'm the only person selling this good and I've determined this is the profit maximizing quantity, I know that the very last person buying this good would be willing to pay how much? Well, the demand curve tells me the consumer's ability and willingness to pay, or their marginal benefit. So if I'm the only person selling this, I know I don't have to charge a price down here, right? My price won't be the same as my marginal revenue for this unit. I know that consumers would be willing to pay this price, right? So that price the monopolist sets, right? They'll first find the optimal quantity the same way a profit maximizing, perfectly competitive firm did. Marginal revenue equals to marginal cost. But then to set the price at that quantity, they'll go up to the demand curve and figure out what price would that consumer be willing to pay. Okay. Any questions on that idea? So a little bit of a different comparison here. I'm going to draw this out again, but allow us to make a slightly different, maybe clean this graph up a little bit and kind of make this comparison between a monopolist and a perfectly competitive firm, right? So let's just assume for a second, we know in these perfectly competitive markets that we have many firms. Let's assume that we've got one firm, right? So their supply curve is the marginal cost. It move around and light shut up on me. So if this was a perfectly competitive market, where would the market equilibrium be? Simply where supply is equal to demand. That would be my perfectly competitive market. Okay. However, we said the monopolist, they don't make a decision using the kind of market demand curve. They make their decisions based off of this twice as steep marginal revenue curve. So what you'll notice is the point where marginal revenue is equal to marginal cost for the monopolist will always be at a lower quantity. And then once they go up to the demand curve to set the price that the monopolist sets will always be greater than that of a perfectly competitive market. Okay. So the price the monopolist sets will always be higher. The quantity that monopolist sets will always be lower than a perfectly competitive market would. Okay. All right. So we kind of already talked through this. How is that price found? Once we decide what that optimal quantity is, we go up to that demand curve because that reflects how much the last consumer is willing to pay for that good. We are the only person selling it, so we're going to charge them that price. Okay. So just another visual in the slides. How would I find the profit maximizing quantity where marginal revenue is equal to marginal cost? I would then go up to my demand curve to kind of find the price. Okay. So I already walked through these as well. The quantity is always going to be lower from a monopolist, right? And the price will always be higher than a perfectly competitive market. Okay. So we already kind of saw that play out. Oh, I probably already jumped the gun on this. I did. So I'll just throw this up here and then I'll kind of make another statement about it. So let's say we already talked about where's this marginal revenue curve come from? We saw from the table it's twice as steep, but I already showed you kind of the math. If you take total revenue, price times quantity, substitute in the demand equation for price, take a derivative to find marginal revenue, it's going to basically be the same as demand, start at the same point, but be twice as steep. All right. So that's kind of where that comes from. I'm going to skip these questions for a second. Well, do here. I'll walk you through an example right now. So we're going to have this up here. So let's assume I didn't just give you this visual depiction, but I actually gave you, I want to make these numbers easy on myself. So let's say this was my demand equation. Okay. If this is my demand equation, and I then think about, let's do an example, and I'm going to simplify this, but I'm going to use this graph to kind of still kind of mention it. Let's assume, because the examples I would give you on the quiz or exam, that you don't have increasing marginal cost, but you simply have constant marginal costs, right? So every unit you sell, right? The additional cost to you to produce it is going to be $20. It kind of makes this a little bit easier. And I can, if we have time today, maybe even walk through an example where we don't have constant marginal cost. But the quiz and the exam, if I ask you questions like this to identify the profit maximizing quantity and price from equations, I'll give you these constant marginal costs. Okay. So what are we really looking for when we're trying to figure out what that profit maximizing quantity is? Well, we're looking for where does the marginal revenue equal my marginal cost? So we set our marginal revenue curve, and I could go ahead and do this and say, okay, what's total revenue? Well, that's price times quantity. What equations I have for demand? 100 minus 10Q, so times Q here. I would have what? 100Q minus 10Q squared. If I wanted to find marginal revenue, that's a derivative of total revenue in respect to quantity. So that would be what? 100 minus 20Q. Okay. Or if I don't have to do this every single time, I can always remember, since we're using linear demand curves, its marginal revenue is always going to start out with the same intercept as demand, but it's going to be twice as steep. So I can go through and do the math and take the derivative, or I can just remember, if I have my demand curve, marginal revenue will start at the same point but be twice as steep. So I'm looking for that quantity where marginal cost is equal to my marginal revenue. Okay. So what am I going to do? Right? Oh, I get this on here. There we go. Yeah. So where is my marginal cost equal to my marginal revenue? Well, my marginal cost was 20. My marginal revenue equation is 100 minus 20Q. So now it's just a little bit of algebra to solve for what quantity would that marginal revenue be equal to marginal cost. So subtract 20 from both sides, add 20Q to both sides. So that cancels. I get 20Q is equal to 80. Divide both sides by 20. And I get that the monopolist profit maximizing quantity would be 4. Okay. So if I'm looking here, I can think about, okay, I just found the profit maximizing quantity for a monopolist is 4. Okay. How would I then find the price that the monopolist can set? Well, what I'm doing there is I'm going to take that profit maximizing quantity of the monopolist. I want to figure out what's the corresponding price or willingness to pay. What point am I at on that demand curve, that willingness to pay of the consumer? So all I'm going to do is plug in that quantity into my original demand curve. Right? So I'll take this demand equation, and for quantity, I'm just going to plug in that value of 4. So the price the monopolist sets here would be 60. Okay. So if we're thinking about this in kind of steps, 1, I'm going to determine my marginal revenue equation. Right. Second step, set marginal revenue equal to marginal cost. Solve for that monopolist equal or profit maximizing quantity. And then kind of the third step, plug that monopolist quantity into our demand equation, and then solve for what that corresponding monopolist price would be. Okay. Any questions on that idea before we keep moving here? Okay. So we can do this with visuals. We can also do this with equations, right? Now, if I'm thinking about just some more general kind of characteristics of these monopolists, and I had these types of questions, right? How would I answer? So what's true for the profit maximizing? We'll kind of work through an example where we find what the profit maximizing quantity is, and then also the price. So what's going to be true about a profit maximizing monopolist? Right? Well, this is where you can always draw things out that kind of help you. Mm-hmm. So if I'm thinking about a monopolist, the first thing I should always do is say, okay, they face the entire demand curve. Their marginal revenue will be twice as steep, and there's going to be some increasing marginal costs. Where marginal cost is equal to marginal revenue, That's that optimal profit maximizing quantity. So what's going to be true at that point? Well, at this point, my marginal cost is equal to my marginal revenue, right? That's how I found that quantity. However, the price I set, I'm always going up to the demand curve. So the price the monopolist sets will always be above their marginal revenue. And because those are the same thing, essentially above their marginal cost as well. So when we're thinking about this monopoly, right, price is not the same as marginal revenue, marginal cost. Marginal revenue and marginal cost will be the same, but they're both going to be below that price the monopolist can get away with charging. Okay. So there, kind of C would be our correct answer. Okay. What if I had a question that looked like this, right? So I've here given you a marginal revenue column. You could have created this yourself, right? So let's just assume we didn't have that. How much, how many units should this monopolist produce if we have a constant marginal cost of 5? Okay. So this is where I kind of make the examples easier sometimes and give you a constant marginal cost. Well, what am I doing? I'm looking for the quantity where marginal cost is equal to my marginal revenue. So how did I find this marginal revenue? Well, for the first 5 units, the change in my total revenue was 45 divided by a change in the quantity of 5. So that would be 9. And then what about going from 5 to 10 units? Well, the change in my total revenue was what? 35 divided by a change in quantity of 5, there it's 7. So when I go from 10 to 15, that's where my marginal revenue is 5. So I know going to that 15th unit, that will be the unit where marginal revenue is equal to my marginal cost. So I'd stop at that 15th unit. If I kept going, well, what's the marginal revenue of going from 15 to 20 units? 3. So now the additional revenue I'm earning is less than the additional costs. It wouldn't make any sense if I'm trying to maximize profits for me to continue to go past that quantity of 15. Okay. Excuse me. All right. And then here's kind of a tricky one, but it is another example of something I said earlier. What if we had 0 marginal costs, right? Should I just produce as many as possible? Well, if I'm trying to maximize my profits, no, because I can't just continue to produce as many as possible, even if the costs are 0, because I know that eventually I'll get to a point where people aren't willing to buy this good, right? They're not willing to pay the price that I'm going to be setting, or sorry, if they are, it's going to be on that portion of my demand curve that's inelastic, and total revenues will be going down. So even if my total costs are 0, I don't want to be at a point where I start to decrease my total revenues. So in an example like this, what's the last unit where marginal revenue is above marginal cost? Looks like it's going from 20 to 25. I still have a positive marginal revenue. So I would kind of choose, right, this point here. Notice total revenue, that's where it's at its maximum point. So I'll stop at 25 units, because if I went to 30, well, now my marginal revenue is negative. That's going to be below my marginal cost. So what's going to be happening if I did go to that 30th unit? I'm just decreasing my total revenues. Doesn't make any sense. Okay. So we know that they're always going to be choosing a quantity where marginal revenue is positive. It's just, what quantity will that be? Well, it depends on what the value of my marginal cost is, like in question 2 that we had there. Okay. All right. Let me think here. So I want to make sure we get through that. Where are we at on time? Oh, we still got 30 minutes. So I think, if I remember correctly, I think we've discussed enough to where we can go through these questions. If not, finish it. Yeah. Okay. So we're not quite there yet. So we got one more thing we have to talk about before we can go through that quiz I forgot about. So we've already kind of made this comparison between the perfectly competitive market and a monopolist, right? So the perfectly competitive market sets the price. The market price is set where supply is equal to demand. That ends up being the market quantity. However, the monopolist, even though they face that same kind of upward sloping marginal cost or supply curve, they're going to choose the quantity where marginal cost is equal to marginal revenue, which will be at a quantity that's below where it hits demand. So this perfectly competitive price and quantity, well, if there's only one firm, their marginal cost will be the entire supply curve. So if they were to act like a perfectly competitive firm, they would set the price and quantity where that marginal cost or the entire supply curve would be equal to the demand curve. They don't. We said they make this profit maximizing decision where this twice as steep marginal revenue curve hits marginal cost. It's always going to be at a lower quantity and a higher price. Okay. So, got already discussed this. This is just called kind of summarized on one slide. So the next thing that we want to talk about is once they choose this profit maximizing point, how can we calculate the monopolist profits? It's going to be very similar or using some of the equations that we use for perfectly competitive firms. So I've now, hopefully we're on board with identifying that profit maximizing quantity for the monopolist, where marginal revenue is equal to marginal cost, going up to the demand curve to find that corresponding price that they'll set. So what will end up being true is the profit equation. So this, remember, started out with profits are simply total revenue minus total costs. Well, we rewrote that for perfectly competitive firms. We could rewrite it the same way for a monopolist. It's also the same as the quantity I'm selling times the difference between price and average total costs. Okay. So here I can see, okay, what would my profits be? Well, here's the price that they're setting. Here's where they're at in the average total cost curve. Here's the quantity. Okay, I've got everything I need to plug into this equation. Well, if price is above average total cost, I know then that the monopolist profits will be positive, right? So these rectangles, when we're calculating profits for monopolist, should always be positive values. And I'll kind of show you an extreme to make this case a little bit more convincing. But it's always going to be at a point where price is above my average total costs. Okay, so we'll look at monopoly versus perfectly competitive profits, right? And then I'll also kind of allude to something that's going to happen. Okay, so let's say I think about got quantity, price here, and here's my marginal cost curve, which if I have one firm, that would also represent the entire supply curve. Okay, so I want to then put in my average total cost. Now, if I'm comparing long run profits, in the long run, we said our fixed costs are zero, so my average total and my average variable cost should be the same thing, and the marginal cost is intersecting them at their minimum point. Okay. So if we had kind of this being our kind of equilibrium price in the long run, if this firm wasn't behaving like a monopolist and instead behaving like a perfectly competitive market, this would be our perfectly competitive price and our perfectly competitive quantity. Remember, we said firms will get to the lowest possible point in their average total cost curve in the long run. That'll be kind of where that equilibrium price is exactly equal to the marginal cost, marginal revenue, average total cost if it was a perfectly competitive firm. Okay. However, for a monopolist, we said they're going to make a decision based off of this twice as steep marginal revenue curve. And I don't draw it down here because we know they'll never choose the negative values. Well, notice for them, well, before we get to them, what were the profits of a perfectly competitive firm? Well, it's the quantity they're selling times the difference between price and average total cost, but their price and average total cost are the same, so the long run profits in a perfectly competitive market were zero. For the monopolist, we said because they face this twice as steep marginal revenue curve, what will end up being true is their quantity they choose is going to be a little bit lower, but at every point past here, notice what's true. The price that they can charge, or the point where we're at on the demand curve, is above our average total cost. So the profits for a monopolist will always be positive, right? That price that they're charging will always be above their average total cost at that profit maximizing point. Any questions on that idea? So positive profits compared to zero, even in the long run for a monopolist. Now, if this was let's say we had a monopolist, just to kind of make this point, they have positive profits, right? And we could calculate that by taking the difference between price, average total cost, multiplying it by the quantity they're producing. What should other firms do? If this firm is earning positive profits, other firms should enter this market. However, we said the reason why monopolies can exist is because we don't have free entry into the market. So if there was free entry, what would firms do? Enter the market. It's no longer a monopoly, and we get pushed back down to this perfectly competitive point. However, there are barriers to entry, which is why the monopolists can kind of continue to operate with positive profits. Okay. So that was kind of the comparison of long-run profits of a monopolist. Get this thing out of here. There we go. To a perfectly competitive firm. Okay. So the one other thing that we'll talk about is the welfare implications of a monopolist. Okay. So I've got something in the slides here, and then I'll draw it out slightly different. So we had the perfectly competitive market. We said marginal costs. There's one firm that would represent all supply. So where does supply equal demand? That's our perfectly competitive equilibrium. We end up at this point where price is equal to the marginal cost is equal to the kind of marginal revenue of the perfectly competitive firm. And here's our perfectly competitive quantity. Okay. This should be the point, these perfectly competitive markets, when we're in the market equilibrium where supply is equal to demand, we said that's the point where total surplus is maximized. Right? So you can kind of think about if I instead have a monopolist, right, they're going to choose the quantity where marginal revenue is equal to marginal cost, but their marginal revenue curve is twice as steep as demand. They then go up here to set the price, right? So notice, what surplus are we now missing out on? Well, there's no units being sold past that quantity the monopolist chooses. So the difference between our supply and demand curve, that represented the total surplus that is now lost in this market. Okay. So another way of thinking about this, and I've got a visual here I think that will help. I'm going to try to draw it out as well. It gets a little bit trickier. So let's think if I had producer surplus from a monopolist. What would that be? Well, it's going to be the difference between the price they're charging, that's their marginal benefit, and the producer or the monopolist's marginal cost. So it would be this entire area here. So there's my producer surplus. What would consumer surplus look like under a monopolist? Right? Well, it's going to be the area below the consumer's marginal benefit, but above the consumer's marginal cost, which is this new higher price. So consumer surplus would be here. So the total surplus would be the sum of those two things. If I did have a perfectly competitive market, I would have had this additional surplus as well. So to kind of highlight that, I think I can do this for us here. Right? So let's say got this market, got my demand curve, I've got my supply, which is the firm's, this monopolist marginal costs, and we had a twice as steep marginal revenue curve. Let's think about where monopolists quantity would be. So that's where marginal revenue is equal to marginal cost. They then go up to the demand curve to set that price. Okay. So we said that the perfectly competitive market would stop where supply is equal to demand. Okay. So I know this is going to get tricky. I wouldn't necessarily suggest maybe even taking notes on this, but kind of watching, and I think it'll kind of help solidify this idea. So if I had a perfectly competitive market, producer surplus is the difference between the marginal benefits and the marginal cost to producers. What is the marginal benefit? That's the price. What's our marginal cost? We kind of have that marginal cost for our supply curve. So for a perfectly competitive market, producer surplus is going to be the area below this price, but above their marginal cost. So producer surplus would be this area here. What would consumer surplus be? Well, once again, it's the difference between the marginal benefits and marginal costs to the consumers. Their marginal benefit is represented by the demand curve. Marginal cost will be the price they pay. So it's a perfectly competitive market, the difference between the demand curve and the price they pay up to that quantity that the market will get to if it's perfectly competitive. Here would be my consumer surplus. Okay. Now, what is producer surplus in a monopoly market? Right? Producer surplus would be the area below the price they're setting, but above their marginal costs, but only up to the quantity they sell. So producer surplus for that monopolist would be this entire kind of area here. What would consumer surplus be? Difference between the demand curve and the new price they're setting. So kind of notice here, this blue area represented consumer surplus in both markets. Okay. Here were the kind of red curves, vertical and horizontal cross. So this red area here was producer surplus in both markets. Okay. What does this area in the middle represent? So if I look at where I had these kind of horizontal red lines, so that was producer surplus for the monopolist. The vertical consumer surplus lines, that was consumer surplus in a perfectly competitive market. This rectangle here kind of represents a transfer of surplus, right? Going from consumers to producers because we have a monopolist. Okay. And then this was consumer and producer surplus before. After we have monopolist, we no longer see any of these units out there on the market. So this surplus would all represent surplus that's lost from our monopolist or our deadweight loss. Okay. It's kind of three different areas there. Or sorry, three. I guess there's technically four. Producer, consumer surplus, but we have this new kind of thing that we haven't really had before, which is like this transfer of surplus. And actually, we kind of did have this. It looks similar. We talked about this in like price ceilings and price floors. Okay. All right. So if I was just thinking about an example, I think I've got the kind of answer already up here. But how would I find deadweight loss? Well, I'm going to look at what was the quantity I was selling in a perfectly competitive market. That's where the demand curve hits that marginal cost or supply. So the quantity of 22. After the monopolist, marginal revenue is equal to marginal cost, so the quantity of 15. So that difference, right? All those units I'm no longer selling from 15 to 22, those 7 units, I'm missing out on the surplus or that area in between demand, the marginal benefits to consumers, and that marginal cost. So the height of that triangle will be what? It goes from 35 to 20. So 15 times, what did we say? It goes from 15 to 20. What did this? I'm missing it. Okay. Must be what? 22.5. So I'd have what? 15 times 7.5 should give me that 56.25. Okay. So 15. Oh, and then multiply by half, right? Because we were looking at a triangle. Okay. All right. So we have 15 minutes. I want to do this and point something out that might help on another problem like that. So let's say I ask you to calculate deadweight loss, and I'll draw this up here so we have a reference. So we've got our demand, supply, which is the marginal cost of the one firm. We have a marginal revenue curve that the monopolist faces. We said the point where supply is equal to demand would be the perfectly competitive quantity. Point where that twice as steep marginal revenue curve hits marginal cost is equal to the monopolist quantity. They then go up to the demand curve to kind of calculate this monopoly price. Okay. So we said, what is the surplus we're missing out on? It's the difference between the supply and the demand curve for all these units the monopolist is no longer selling. So we know this is our deadweight loss. So it's always going to be the area of a triangle. We're keeping everything linear here. What's the base of that triangle always going to be? It's always going to be, so our deadweight loss will always be the difference between the quantity a monopolist would choose and the quantity a perfectly competitive market would choose, right? Or the number of units we're no longer seeing on the market from having a monopolist. What is the height always going to be? Well, I've got the price here, What will this always be? This is going to be the marginal revenue of the monopolist at that quantity. So the height of my triangle will always be the difference between the price and the marginal revenue of the monopolist at that monopoly quantity. And then once again, linear supply and demand curves, we would then also have to always multiply by 1/2. So you can look at it with numbers and visually on a graph, but those numbers are always going to represent the exact same things, right? So it's the reduction in the number of units, that difference in between the price that they can charge and what their marginal revenue or their marginal costs are. And then because we have linear supply and demand curves, it gets multiplied by 1/2. Okay. All right. Oh, I want to exit out of the slides. There we go. So what if we had a question like this, right, instead? So just working through more problems. This is our participation quiz. I have these because I think it's good to just kind of work through more examples. But also a way for me to kind of actually give you guys a way to earn, I wouldn't say easy points, but points for participating and being engaged in the class. So if I've got this cost structure, what's the profit maximizing price and quantity the monopolist will set? If this is a question you see in the quiz, hopefully this is an easy one, right? Because all you're going to do is look for the quantity where marginal cost is equal to marginal revenue. Looks like that's at a quantity of here of 15. However, the price will not be 20. Here we're going to go up to the demand curve to figure out what price the monopolist would set. Looks like that's going to be a price of 35. Okay. Now, one thing I'll point out here to be careful about is just, if you made this mistake where you think the price is 20, one thing you could use to kind of help you identify, like, wait, something's not adding up, that price would be below average total cost, which would mean profits for the monopolist would be what? Negative. When we have a single price monopolist in the long run, the profits would always be positive. Okay. So, right, if I think that the price is 20 and that's below, and I know that, oh, monopolist profits can't be negative, I must have made a mistake. Oh, yeah, that's right. This point where marginal revenue is equal to marginal cost identifies the quantity the monopolist chooses, but the price is set by going up to our demand curve. Okay. And then if I wanted to actually calculate the profits, I get to go back to using my same profit equation. I'm just going to take the quantity that they're selling, so that we just said was 15, multiply that by the difference between price of 35 and their average total cost at that quantity. So it looks like here it'd be what, 25, 35, so 10 times 15 should give me profits of 150. Okay. So we're using that same profit equation we were before. It's just we now are plugging in the monopolist's quantity and the monopolist price. Okay. Excuse me. All right. So I want to save price discrimination for next class. We've got natural monopolies. Well, got 10 minutes. It'll make tomorrow a little bit easier. Let's just think about setting us up for what we'll start talking about tomorrow. So we should hopefully have a little bit more time to go through some more practice problems and stuff like we did for module 10. So everything we've talked about to this point is assuming that the monopolist is setting a single price, right? When they're selling this product out there in the market, they have to set a single price. We know that there's going to be price discrimination from producers, specifically monopolists. So really all price discrimination is that I'm charging different consumers different prices, or I'm charging different prices for a different number of units. So usually I'll think about this in terms of identifying consumers who are willing to pay more or less, but this could be the same consumer and charging them different prices for the first unit versus the fifth. Okay. So, what should this do? Well, before, when I was setting a single price, that potentially was the marginal benefit of the last consumer, but every consumer before that would have been willing to pay a higher amount, right? So if I think about this single price monopolist, right, I had a constant marginal cost just to simplify this. Every unit here, the price the monopolist was setting, they actually could have chose a higher price, right? The consumer would have been willing to pay a higher price, for these lower quantities. So there's some surplus out there, right? We said before we had this transfer of surplus from producers to consumers, right? Here with the constant marginal cost, that also is our monopoly profit. How can the monopolist extract or get some of this consumer surplus, turn it into their producer surplus or into monopoly profits? Okay. So we had deadweight loss, right? This is our single price monopolist. What a perfectly price discriminating monopolist can do, right, is, there we go, for every single unit in this range, where before I was charging every consumer this price, I start to charge people exactly how much they're willing to pay. So for all these units I was selling before as a single price monopolist, I'm now making more surplus off each unit if I can charge different consumers different prices. So I'm kind of gaining some surplus there. Now, past this quantity, if I'm able to price discriminate, what price do I charge the consumer? Exactly what they're willing to pay. So for a price discriminating monopolist, they can sell more units because they're charging these consumers a lower price, but they're still going to be extracting some surplus for themselves, right? The price they're charging, difference between that and their marginal cost, they're going to be gaining some surplus here as well. So for the perfect price discriminating monopolist, all of total surplus will end up becoming producer surplus. Okay. So another way of thinking about this, it's a little bit, don't just kind of have these constant marginal costs. Like let's say I had my demand curve, got my supply curve, and I'm thinking about what I want to chart. Well, if I can identify, so this is, I always say like a really good example of price discrimination. Here we can kind of simplify this down to thinking about like one consumer. So if I go to the store, I just went the other day and I had like these, I forget what it was, but it was like buy two, get one free, right? Now that's an extreme example. So we'll say if I could perfectly price discriminate, I would just charge different prices. But buying two and getting the third free essentially is changing the price, right? When I buy that third, if I want to buy that second unit or that third unit. So if I could identify how much someone is willing to pay for the very first unit of my good, that's the price that I would charge for that first unit. And then if I could identify what's the price they're willing to pay for the second unit of that good, then I would say, okay, if you buy two, this will be the price of the second. And then if you buy three of this good, well, here's the price that you'll have to pay for the third. So I'm still guaranteeing that when you only buy one, you're going to have to pay that higher price. But then as you buy more, I kind of give you these quantity discounts. As you buy more, I think like my wife goes here and it's a better example because they have a lot of different combinations like crumble cookies, right? If you just buy one, the price is much higher than if you buy three, and it's much higher than if you buy six per cookie. And so that's the idea basically of price discrimination. So what is producer surplus? It's the difference between the marginal benefits and the marginal costs. But if I'm charging these different prices, right, what is the marginal benefit? It simply becomes not just the price I'm charging, it is my demand curve, right? That's how I'm choosing these prices. What represents my marginal cost? Well, that was like my supply curve. So for every unit, the difference between price and the supply, all of this is producer surplus. Right? Well, if I had a perfectly competitive market, where would the quantity be? Where supply is equal to demand. Now, there we would have a perfectly competitive price, and we would have, okay, what's consumer surplus? The difference between the price and the demand curve, right? What's producer surplus? Difference between price and the supply curve. So we end up with, if you can perfectly price discriminate, the monopolist, we have zero deadweight loss, right? We've maximized total surplus. The only problem is all of surplus has now become producer surplus when they're able to price discriminate. Okay. What is my consumer surplus? Well, if that's the difference between the marginal benefits and the marginal costs, if this is a price discriminating monopolist, the price they're paying is exactly equal to their demand curve. So this difference would always be 0. So with perfect price discrimination, we have no deadweight loss in this market. So that might sound like a good thing. The only problem is, even though there's no deadweight loss in the market, all of consumer surplus is gone and it's been transferred over. So once again, we can kind of think about this blue area used to be consumer surplus. Now that's red, so now it's producer. So kind of this triangle here would represent a transfer of surplus from consumers to producers if the producers are able to perfectly price discriminate. Any questions there? All right, so we get consumer surplus is 0, all of total surplus is producer surplus, and we have no deadweight loss. Now notice, we also get to that same quantity of a perfectly competitive market if we are able to perfectly price discriminate. Okay. So next class, I think what we'll start with is comparing now not a price discriminating monopolist to a perfectly competitive market, but we'll compare the price discriminating monopolist more to this single price monopolist, walk through some of those, kind of that comparison. We'll talk about natural monopolies. I've got some cost change things we can kind of talk about. Let me think if there's anything else I wanted to mention here today. And like I said, I think that we should have some time tomorrow to work through some of those practice problems. So if there's not any questions there, so we had those quiz questions that we already answered. So that'll be due by the end of the day Sunday. I'm going to end the recording there.